Hi everybody, thanks for checking out this video here. We will discuss a classic distance rate time problem. This is the same problem that we looked at in class today, but it's presented here with a little verbal description to just help you if you get stuck on some of those problems. It hopefully will give you some tips. Alright, so this problem, as you might recall, started off with this. Here's the problem. Joe rode his bicycle up Old Man Mountain 15 miles and then he rode back down again on the same road. The entire trip took 3 hours and 20 minutes, and his average speed down the mountain was 3 times the speed going up. And the problem is, find Joe's speed going up the mountain. Okay, so anytime you're presented with a word problem, one of the first things to do, after you've read it very carefully, is to try and ascertain the important facts of the problem. First fact here is that it was 15 miles up the road and down the same road. So the fact that he goes up and down the same road is important because it's the same distance. The next fact is that the entire trip took 3 hours and 20 minutes. That will help us. So the total time, 3 hours and 20 minutes. The next fact is that the speed going down was 3 times the speed going up. That sort of makes sense. And so it's a nice multiplier there to deal with. Now, in addition to using the facts from the problem, we will call upon our prodigious math background here to add some other tools for us to use here. And in this particular problem, the thing that's most important is d equals rt. Distance equals rate times time, or sometimes people call that the dirt equation. It's very easy to remember, d equals rt, but there are 2 very important variations of that equation. One of them is the rate equals distance over time. The other one is time equals distance over the rate. It's a very important algebraic structure for that equation. All right, so if we take a look at the facts, again, to kind of summarize some of them, one of them is that the total distance, as we mentioned, was 30 miles total. And the other one is that this might surprise you a little bit. We'd probably run into this a little bit later on, but I'm putting it here to help things move things along a little. 3 hours and 20 minutes is kind of an odd time. So be on the lookout for this. If you can rewrite that hours, minutes total there as a fraction, it could very well be an advantage for you when you write your equation. 3 hours and 20 minutes is 3 hours plus 1/3 of an hour, 3 1/3 hours, which you could simplify down to 10/3 hours. Okay, we'll come back to that in a little bit later, but just kind of throw that in here at the beginning. So once you've kind of gotten all the facts, the next critically important step is to identify your variable. And in this case, we will use the actual question in the problem, which was to find Joe's speed going uphill. So since his speed going uphill, we're asked to find the speed uphill, that's going to be our variable x. Okay, so when we take a look at that, going up 15 miles, the rate was x. That's the speed going up. That's what we're going to call it. We don't know what the time for that was, but we do know that the time equals 15 over x. So we've got d, we've got 15. R, we're calling that our variable x. T, we don't know that, but it's 15 over x. The same thing can be said for the downhill portion of the trip. 15 miles again. The rate is 3x this time because it's 3 times faster going down, and so therefore the time going down is 15 over 3x. Now remember, the total time for the trip was, we called it 10/3, 3 hours and 20 minutes. And so since that number, 15 over x, plus that number, 15 over 3x, equals the total time of 10/3 hours, we therefore have our equation just, bam, right there. The sum of those 2 times equals 10/3. All right, there we go. That's our equation. Okay? Time going up, that's 15 over x. Plus the time going down, that's 15 over 3x, equals 10/3. And now that equation is pretty easy to solve. We can solve that quickly. Just let me demonstrate the multiply by the common denominator trick, fraction busting. And if I multiply that equation by 3x, my first term turns out to be just 45. My second term turns out to be 15. And the last term, 10/3 times 3x, is just 10x. And 45 plus 15 equals 10x then. Easy to solve. You get x equals 6 miles per hour. There's our the answer to our problem, Joe was riding 6 miles per hour up the hill. So let's summarize some of these tips here before we call it a day here on this little video. First one, read very carefully. Read it a couple of times, all right? There could be some little tiny bit of information in there that you might skip the first time. Next tip, gather your facts. Look at all the numbers in the problem, gather all the important facts from the problem, and include your previous prodigious math background knowledge, okay? That can be very important there and can sometimes be the key that ties things together. The next thing, very, very important to identify explicitly what the variable is for your equation. And if you're in any doubt, just reread the question itself, and that will guide you to what the variable should represent. So identify your variable according to the question that you are answering. Okay? And the last tip is hardly even a tip. Just write the equation and solve it. That's usually the easiest part of the whole problem. And there you're done. So thanks for watching this little video. I hope it was helpful, and carry on, folks.